Okay, so here I've been given the equation, okay, in graphing form, so I know what this looks like. I'm asked to find a symmetrical point, 2, 4, 7. Let's first of all, let's just draw this in. So 3 over 5 up, maybe somewhere around here. It's going to be parabola, it looks like that. And we're talking about a symmetrical point, so we're going to do that. And at 4 over 7 up, 4, 7, that's going to look like that. And I'm being asked to find the symmetrical point over here. Okay, so we could probably just count this, right? So it's 1 over this way, 1 over this way, so that should be 2, 7. Okay, so that's perfectly fine. We can just solve it in that way. And we could use this line of symmetry to do that. So I'm going to show you a few different ways we can do this as well, other than just visually and kind of just doing it more or less kind of informally. To formalize this a little bit, which is important, we really want to formalize this. So I'm just going to say this. I'm going to just call that point A. And to formalize this, what I could do is this. I know that there's a relationship between the symmetrical points and the middle point, and the relationship looks like this. If I add the outside points, A plus 4 and divide it by 2, I'm going to equal the middle. Right? This is a formula to calculate average or middle. Okay, so this is a very useful thing to use, especially for parabolas, since they are symmetrical, and you often can find a relationship with middle. So this is my average. So if I want to solve for A, I just algebraically rearrange this. I get A plus 4. A plus 4 is equal to 6, and that makes A equal to 2 when I solve this algebraically. Now, why would we do this? Well, this is easy problem to do kind of informally, but once we start dealing with unknown parts, we really need to understand the relationship. And what is the mathematical relationship? What is the math involved in this relationship? And it's really important to understand the mathematical principles behind this idea of symmetry. And so this is a nice, simple way to be able to use that relationship, but we have to recognize that relationship first. So I want you to be able to connect this idea of middle to this idea of middle, the average formula to the idea of middle algebraically. The other way that this could have been done, okay, so this is now a separate method. What I could do is solve this algebraically because we always can plug this coordinate into back into our equation. Now, we don't want to plug 4 and 7 in. We want to say, well, there is some coordinate A7 that is on this parabola. Okay, and then we can plug that coordinate in. I'm just going to do this in green here. I'm going to say that's A, and we're just going to say that A and 7 are on this graph. So y equals 7, x equals A, and then I can actually just solve this. So this is method 2, and I could solve this. I get 2 is equal to 2a minus 3 squared. Okay, this is going to be equal to 0. Equal to 1. Divide by 2, and I get a minus 3 squared equals 1. Well, a minus 3 can equal plus minus 1. Okay, so I'm going to write this as two separate equations equal 1, or a minus 3 can equal negative 1. A is equal to 4. Well, I already knew that because that was given to me at the beginning. But the other a here that I'm solving for, a equals 2. That's the one I'm looking for. So we could have solved it algebraically like this. This is kind of a brute force method. It does work, but it's not very useful, and it gets difficult to use once you get to harder problems. This is a much better method, I think, because we're actually looking at the math behind this and then using the property of symmetry. Here we're just using kind of brute force algebra. Well, we can just plug in things and just kind of see what happens.